Hey guys, Mr. Milton here, helping you out with a quick radical review. These are radical rules that you should have learned in Algebra 1, but you might have kind of lapsed over the summer. Okay, there's two properties to radicals that we can use, that we'll use for this at least. The first is radical AB. Okay, so what you see in here is really, when you have two letters together, it's just the product, right? We're multiplying these two. And the thing that we can see here is that if I have radical A times B, then I can rewrite this as radical A times radical B. Okay, we're going to use this as we simplify our radicals, that if a number can be multiplied by two things, we can rewrite those radicals as the product of two radicals. Okay, and that'll help us out because if we have a squared number here, like we have, the radical square root of a square number, these two are basically inverse operations. So the square root of a squared just leaves us with a. Okay, and as we simplify radicals, what we want to do is remove all the squared terms out and leave any unsquared terms inside, and that will be our simplified radical. Okay, recall that the special numbers that we probably will want to be, or keep our eyes open for, are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169. If you remember 196 and 225, those are the perfect squares up till 15. Okay, so these are the ones that should be at the top of your, on the tip of your tongue as you're doing these problems. All right, and so this is how this works. A couple ways you can think about it, and I've only really seen it taught two ways. And so I kind of do a hybrid of both. If you can, so one way that I've been taught is look for the highest perfect square. Okay. The negatives of that is sometimes it takes a long time to do it. The other way is just find two numbers that multiply to give you 48. Okay, and do that. If you do a mixture, like if I can think of the product that goes here, then you should be able to do this quickly without having to do too many arithmetic Olympics to get through it. Okay, so we'll just do the number tree. Okay, and I'm going to think of two numbers that multiply to give me 48. Okay, and I'll do this the long way the first time and the short way second, just so you can see how that comes out. So 2 times 24 is 48. Okay, the only rule to the number tree is you cannot use the number or 1. So there's no other way for me to multiply 2 without using 2. So I'm going to circle that just so I know that that branch of the number tree is dead. Okay, to multiply to give 24, I've got 2 times 12. To multiply to get 12, 2 times 6. To multiply 6, 2 times 3. And notice now that all my branches are circled, they're dead. So what I do now, or what I can do now, is I can write all my circle branches here, 4 2's and a 3. Okay, all pairs I will remove, take outside of the radical sign, or the radicand, and then I'll write them on the outside. So I have a pair of 2's, it's 1, another pair of 2's is 2, and on the inside without a pair, so it doesn't get to leave, is 3. At the end of my problem, the numbers that remain inside are multiplied together, and the numbers that are taken outside are multiplied together. So 2 and 2 are multiplied together, gives me 4. 3's by itself gives me 3. Okay, that was a long way of doing that. Okay, if I chose better numbers, let's say, so if I have radical 48, and I said, hey, 16 times 3. 3 is a prime number, I'm done. But notice that 16 is in this perfect list of numbers. Okay, 16 is 4 squared. I could make my tree a lot quicker and say, okay, these 4's go on the outside, and this 3 stays inside. Okay, so it would have been a smaller tree, same answer. So you can do this either way. Okay, your number sense can make it faster or slower, but as long as you're doing the multiplication correctly and taking the pairs out correctly, you should get the right answer. Okay, number 2. As I look number 2, ends in a 50. I know it should be divisible by 25. So 25 times 6. Scoot this up. 25 times 6. 5 is one of those perfect squares. 5 and 5. Or 25 is one of those perfect squares. 5 and 5. And then 6 breaks down to 2 and 3. So on this step I have 5 times 5 times 2 times 3. These are the things that are inside. I take my pair out. I'm left with 2 times 3 on the inside. So my answer should be 5 radical 6. Okay. And then 252, as I look at this, what goes into that? 7, 9. Okay, it's divisible by 3. So I'm going to go 3 times 70, nope, 84. Okay, so 84, I'm going to do 4 times 21. Okay, 4 breaks down to 2 and 2. Dead branches now. 7 and 3. Dead branches now. So as I look at all my circled branches, my dead ends of the tree, I've got 2 times 2 times 3 times 3 times 7. 2 2s, 2 3s, and a 7. So 2 goes on the outside, 3 goes on the outside, 7 doesn't have a pair. 2 times 3, those are the numbers I brought to the outside. 7 inside, ooh, at the bottom of the screen. Okay, so 2 times 3 is 6, 6 radical 7. Alright, so that's the radical review from Friday. If you need help going through that, you've got that. If you have more questions, make sure you ask during the class period. See ya.